Hello and welcome to the next video of Python Bytes. In this video we will see a problem where we have to rotate a matrix n by n clockwise. Let us understand how to rotate a matrix. So for this we are going to rotate a matrix clockwise and the given matrix is n by n. So that means the number of rows and number of columns are same. Let us start with an example. Let us take a 3 by 3 matrix and let us write down the elements of that. So a 2D matrix is a compound list. So it is a list inside a list. So we will have the first row, second row, and the third row. Now when we rotate this matrix clockwise, the expected result is, so this was the original, and when we rotate it, we write it as new, and when we write it as new, when we rotate it, we'll get it the elements as 7, 4, 1. The second row becomes 8, 5, 2, and the third row becomes 9, 6, 3. Now to understand how to make this operation, how to finish this operation of rotating it clockwise, let us first understand how to write these matrices in the index form. So the original matrix, we will write the indexes. The index is, so it starts with the first element in this is the row and the second element is the column. So we are going to write a tuple, and now we are in the first row, second column. So we start with 0 and because the index starts with 0, so it is 0, 0, 0, 1 and 0, 2. This is our first list. Now when we go to second row, 0, 1, 0, 1, 1 and 1, 2. So this becomes our second list, and the third list is 2, 0, 2, 1 and 2, 2. This becomes our third list. If we just rotate this or the list of indexes clockwise, what we will get is, we will get 2, 0, 1, 0, 0, 0. This becomes our first row. Second row becomes 2, 1. Oh, I definitely did a mistake over here. It was a 0. So this becomes 1, 1 and this becomes 0, 1. This becomes our second row. The third row is 2, 2, 1, 2 and 0, 2. This becomes our third row. Now to get these operations executed, there are two operations. There are two steps basically, and we'll call it operations. The first one is interchange elements. So when we do interchange of elements, we will take the new I element and j element is equal to original j and I. So when we do this particular operation on the original, what we get is, we will be interchanging the elements. So in the new one, 0, 0 will stay at the same place. This 0, 1 position will be occupied by 1, 0, and this 0, 2 position will be occupied by 2, 0. And thus we will do the next row, 0, 1, 1, 1, 2, 1. This becomes second row. The third row is 0, 2, 1, 2 and 2, 2. So now we have finished the first operation. It is not what we want. So we will do the second operation, and that is flipping. Let me write it right. Flipping each row. So when we flip each row, so we'll take this and we'll flip. So the last elements become the first and the first will become the last. So we'll just reverse these lists, and what we get over here is 2, 0, 1, 0, 0, 0. This becomes our first row. The second row becomes 2 comma 1, 1 comma 1 and 0 comma 1, second row. And the third row is 2 comma 2, 1 comma 2 and 0 comma 2. This becomes our third row. Now we see that the result we got over here is equal to this, what was expected. So now we will see how to do these two operations in the code, and let us jump to the coding part. Let us start coding the problem. So the problem that we are coding today is rotating the matrix clockwise. So what do we mean by clockwise? So when we are given a matrix, for example, like this, when we rotate it, the first column becomes the first row. So if you see the first column 741 is now become the first row, that is 741. So now in the explanation we have seen there are two steps or two operations that we have to do to rotate a matrix of n by n clockwise. So let us code that. So we have created a function rotate clockwise, and we have given an input over here. The example input is a 4 by 4 matrix, and then we are going to call that, and we are going to give an argument of the old matrix, and we'll print when the matrix that is returned, we'll print over here, and the returned matrix will be rotated clockwise. So let us start coding. So we will use the module numpy for this. So we'll convert our given matrix, which is a compound list, into a numpy array. So we'll use the same variable matrix, and we will convert it using the function matrix that is there with numpy. So now we have converted the given compound list into a numpy array object. We'll print this matrix, and let us run this script and see that the given array, the given compound list is converted into a numpy array. Also, this array that input is given can be of any type. That can be n by n. That means we have to find what is the length of the row and the column, which is same, but we'll find the length using the inbuilt function of Python, that is length. Now we need a new matrix which will store the rotated, when we rotate it clockwise, it will store all the values in that. So we need new matrix which we will return in the end. We are going to initiate this matrix using numpy zeros function. So numpy zeros function will create an array of whatever size we give. So we are going to give the size as n comma n over here because we need that size, and all the elements of this new matrix at initial stage when we use zeros will be a float object, but we need an integer, so we define the second argument, that is integer. This will create an integer type matrix over here. Now we will start doing our operation 1, that is interchanging the elements. To interchange the elements we need two for loops. So for I in range, so this is the range is the number of rows, and for the second one for j in range n. So because it's a n by n matrix, both the ranges will be n, and now we will do the operation of interchanging. So in numpy we do not use square brackets to denote the indexes. We use one single square bracket. We do not use multiple where for 2D, and we just give the row comma column. So over here is row is I, column is j. So in list we use two square brackets to give indexes, but in numpy we do not. So we use j comma I, and this is how we will have and finished our operation 1, that is interchanging the elements. The second operation that we are going to do is flipping the rows. So operation 2 is flipping rows, and that can also be done with a for loop for I in range n, and then we flip it. To flip, so we have to store the new matrix value I, and then numpy has a function called as flip, and we give an input of our new matrix. So new matrix and I. So when there is only single value of index, that means the row, it will take the complete row, and now here it is flipped. And if we return new matrix, we will see that what is the output. Let us run it, and now over here we see the original matrix was 1 2 3 4, and when it is rotated clockwise 90 degrees, this column, the first column has been replaced as a row, first row. So now we have finished our operation of rotating the matrix in a clockwise 90-degree direction. We have used 3 for loops, and if you see this for loop and this for loop, both the for loops in operations are same. So we can basically eliminate this for loop, and we can just, once we are out of the first for loop here, we have already interchanged all the elements in the first row, that the row that we are doing. So over here the row 0 will be there, so we can even flip it in that same step. So we can eliminate one extra for loop, and we can reduce the operation time in this. So if we now run it, we get the same results. So this doesn't change the result, that means, but this, as we have optimized the time, the complexity, the memory usage, because we are running less number of for loops now. Now my question over here for you, all the viewers or all the Python coders, is, can you create a function that will rotate the matrix anti-clockwise 90 degrees? Thank you for watching this video. I hope you got a hang of how to rotate a matrix n by n clockwise. Please post your solution to rotating the matrix anti-clockwise in the comment section. Please like this video and subscribe to the channel. Find more content related to problem solving in the top right corner. Goodbye till next time. Keep coding.